Let f be the function given by f of x equals kx over x squared plus 1, where k is a constant. For what values of k, if any, is f strictly decreasing on the open interval from -1 to 1, meaning its derivative would be always negative. So we've got to look, and this would be no calculator. What's the derivative? Well, the derivative is low d high, k is a constant, minus high d low over low squared. Now that low squared isn't really going to do anything for us because that's going to be always positive and always defined. So we're just going to really base our work on the top. When is x squared plus 1 k minus kx x squared plus 1 less than 0? Remember the interval from -1 to 1. So let's kind of clean that up a little bit. Kx squared plus k minus kx cubed minus kx. And then let's kind of look at our options. Factor out that k. We've got a negative x cubed plus x squared minus x plus 1. Where would that be equal to 0 at? Let's take a look here. Negative x plus 1. It's going to be an x squared plus x. X squared plus 1. There's our factors there. So again, this will never equal 0. So something changes at x equals 1. So as I'm looking at this, any values of x from -1 to 1 are always going to be positive. Picture, until I put the 1 in, this is going to be a negative something plus is going to be positive times a positive. So really we're just looking at k. So k has to be less than 0. As long as k is less than 0, it is strictly decreasing on the interval. Kind of a tough one. Got a differential equation here, dy dx equals 5y squared. We got to solve it with the initial condition, y of 0 equals 3. Let's give it a shot. Separate the variables. dy over y squared equals dx 5. I bet we got a couple of favorite mistakes. This is a y to the -2. We don't need a natural log. You should have noticed that one. None of this had an e over here, I guess. Oh, I guess we did have an e there. Let's take a look. So y to the -2 becomes y to the -1 times -1, or divided by -1, equals 5x plus c. Divide by the -1. Y to the -1 equals -5x plus c. Let's throw that initial condition in. Y of 0 is 3. So y is 3, so 1/3. You know what, let's clean it up first, maybe that'll be easier. Y equals 1 over -5x plus c. Now let's try it. Put the initial condition in. 3 equals 1 over, nah, I don't think it's going to be any easier. C. So it looks like C is going to be 1/3. If C is 1/3, I see y equals 1 over negative 5x plus 1/3. Totally acceptable on a calculus test, but we've got to figure out where that is in here. I think back to pre-calc. If I multiply this by 3 and 3, I get 3 over negative 15x plus 1, which is the same as 1 minus 15x. There we go. And we'll try this one. The old average rate of change, instant rate of change. Limit as h goes to 0 of the sine of pi over 3 plus h minus the sine of pi over 3 over h is. So we've got to recognize this as the definition of the derivative. So what do we find the derivative of? We're finding the derivative of. The definition of the derivative is f, the limit as h goes to 0 of f of x plus h minus f of x over h. So what is f of x? F of x is sine. Where are we finding the derivative at? We're finding the derivative at pi over 3. What's the derivative of sine? Cosine of pi over 3 is 1/2. If we recognize it for what it is, that problem's pretty awesome.